Hey guys, welcome to another video. This one's going to be dedicated to learning what backwards PEMDAS is. And if you don't know what PEMDAS is, I'll explain it. But backwards PEMDAS is really when you're solving for a variable from an equation that they would give you. So they would be like solve for x when 2x minus 6 equals 8, something like that. So yeah, that's what this video is going to be about. And I'll just jump into it right now. So PEMDAS is the method that you use to solve equations. It's just the order in which you go when you solve them. So the P is for parentheses, the E is for exponents, the M is for multiplication, the D is for division, A is for addition, and S is for subtraction. And that's just the order in which you go to solve the problem, right? So when I say backwards PEMDAS, it's for solving for the variable. So you're basically taking an equation and going backwards with it, using this method to solve it just backwards. Alright, so I'll start to get into what I mean by that. So let's look at this first example of 3x minus 6 equals 18. This is one of the more basic examples that you'll see where you only have to do really 2 to 3 steps to find out what the variable is, and it's pretty easy to follow along with the PEMDAS track that you're doing, right? So let's start doing backwards PEMDAS. So what our first thing is, what we see here is, if you were to go backwards, it's subtraction, addition, division, multiplication, exponents, and parentheses. So what I'm going to look for first is subtraction. So right now, I don't really see any subtraction to help cancel out a value, so I'm going to move on. And then I see addition. Addition in this case can really help us because if you didn't know already, addition and subtraction cancel each other out, and multiplication and division cancel each other out as well. Right, so in this case, I see addition. I see where addition can be added to this problem to help solve it and help kind of cancel out values, right? So here we go. What we're going to look for first is addition in this one, and what I see here with this minus 6 is something that we can start to cancel out. So what I'm going to do is add 6 to both sides. Alright. And this is really just to help with the process of getting this x alone on one side. That's what our main objective is here. It's x equals something, and x has to be alone. So that's how you're going to deconstruct this problem and do backwards PEMDAS to try to get to that point. Right, so what I have is adding 6 to both sides. Remember, you have to, whatever you do on one side, you have to do to the other. That is very important, just because it can't really work if you only do it for half the problem, right? So if you finish this out, it's 3x, and then you cancel this out because negative 6 plus 6 equals 0. And that just equals, so then you add 18 plus 6 on this side, which equals 24. Alright, so remember what I kept saying about how you want to get that x alone, right? So in this case, the way to get that x alone, you see it's 3 times x equals 24. And remember what I was saying earlier about what cancels each other out, what two pairs cancel each other out. And in this case, it's 3 times x. So if you think about that for 1 second, you say, okay, what do I know that cancels out multiplication? And in this case, it's division, right? So that's how you're going to get this x alone in this problem. You're going to divide it by 3. So you divide both sides by 3. And then you just get that x alone because 3x divided by 3 equals just x. And that is equal to 24 divided by 3, which is 8. And remember, you'll have your calculator, so if you couldn't do that in your head, make sure you use your calculator. It'll be very effective for you and very easy to use. So in this case, our final answer equals x, and I can kind of review that. So first off, we looked and we saw that we had minus 6, so the only way to cancel that out is with addition. So we added 6 to both sides, and then that's how you get the 6's to cancel out. Right, so then you get 3x equals 24 once you make sure the 6 is all ready to go. And then, since it's 3 times x, you use division to cancel that out to get that x finally alone. And from that, you get x equals 8. Remember to divide by 3 on both sides. So over here, this is going to be one of your harder examples because it doesn't follow exactly what I did up here. You need one extra step to really understand like how you're going to do backwards PEMDAS. So let's get into it. So the second example is x minus 1 divided by 3 equals k, and then you know that k equals 3 when they want you to solve it, right? So let's mark what k is so we can rewrite the problem. 3 equals 3. So the reason that this problem is a little bit different than what we did over here is because it has a denominator. And what I like to think of the denominator first is, the reason that you have to do the denominator first is because it's really saying 1/3 times 1, or x minus 1, right? That's what it's basically saying, because if you were to multiply this whole thing, it would just be everything divided by 3, right? So it's the same, this is the same look. All you're really doing is making sure that you do that denominator first. And that's why it's a little bit different. So in this problem, you want to make sure that you cancel out this denominator first, just so it's easier for you to do the problem, and that's always the first step. If you see a denominator over or under things, under the x values, make sure, or any variable in that case actually, make sure that you get that denominator out first, because it'll help you with the rest of the problem and it'll make it a lot less confusing. Right, so I rewrote it as x minus 1 over 3 equals 3. So what we're first going to look at is how do we get this denominator out. So it's going to be kind of like what I did with this first problem. We're going to look at, so this is really it divided by 3. And remember, what is the one thing that can cancel out division? Multiplication, right? So what we're going to do is multiply both sides by 3. Right, so if you just do times and times 3, right? So then that'll cancel out this denominator for you, and it'll just get x minus 1. And then remember, what you do to one side, you have to do to the other. So then it would just be 3 times that 3. Right? And that's how you get to that step right there. And then you pretty much know what you do there, because it's kind of like this problem. We're going to look at it and we're going to see, okay, this is a minus 1. What is the only thing that can cancel out subtraction? Addition. All right, so you're going to add 1 to both sides. So x, in this case, has equal 10. And that would be your final answer, right? So just a little recap of what we did in this video. We talked about backwards PEMDAS, and really the two examples that you'll see in a lot of cases that either the problem will be shaped like that, or you'll have to get to that point and then solve for the variable, right? So it's really solving for a variable in an equation. And remember, PEMDAS stands for parentheses, exponents, multiplication, division, addition, and then subtraction last. And these are the two examples that you'll see most often. This one is pretty basic since it does not have a denominator, and it's much easier to do because everything is on the same level basically. So all you have to do is remember what cancels what out. In this problem, it was addition that canceled out the subtraction, and then you did division to cancel out the multiplication, and you got your final answer of x equals 8. And then over here, you have the denominator, so you can make sure that you get that denominator out first, and you do that simply by finding out what cancels out division, which is multiplication, and you multiplied it, and then you get x minus 1 equals 9, and you have that minus 1, so you need addition to cancel it out. So you add 1 to both sides, and your final answer would be 10 in this case. Right, so I hope you understood that. Let me know if you have any questions, and thank you guys for watching.